This is for module 2.2, creating and solving equations. So our essential question is, how do you use an equation to model and solve real-world or problems, right? Our answer is basically we use a verbal description. So everything in life has to be pretty much synthesized in a verbal description or a table. Sometimes we use tables in Algebra 1. Okay, that's a great way to also tell differences of certain situations. To write an equation, all right? Solve the equation. All right, we're going to do that. Okay, and then we're going to check the answer and make sure it makes sense. All right, so let's look at some examples and we'll get into this. So creating equations from verbal descriptions. So example one, we got two friends here, Corey, Walter. Right, they go to a movie. Each of their tickets costs the same amount. All right, so there's two people, right? So I'm thinking, all right, the cost of a ticket, let's say T for ticket. Okay, um, so tickets, right? They buy two of them, right? And they're going to be the same price. So tickets going to be represented with the variable or the letter T. Okay, and remember, there's two tickets, right? There's two of them, and they share a frozen yogurt that cost $5.50. Okay, so that's like a little additional cost there. The total amount in the end of the night was $19.90. So how can we write the equation that describes the situation? That's the main question. All right, so let's take a look at this. So we have twice the cost of a ticket because we have two tickets. All right, and which is another way of saying plus or sum the cost of the frozen yogurt, which was $5.50. Okay, so we have that, right? We have that, and then the total cost that they spent at that night, which was $19.90. So this would be a great way of writing an equation to represent that scenario. Now, the reason we do that in real life is because maybe we have to figure out, well, how much do the tickets cost? Um, Corey and Walter, because maybe you were wanting to buy a ticket and you're just trying to figure out, okay, well, how much are those tickets? So basically, this is where you use properties of equality, right? So how do you get rid of a plus $5.50 minus, right? So this is the solving part of it. And just remember what you do to one side, you do to the other, right? So you got 40 cents there, right? 90 minus 50, and then $14 there. And these cancel out. And then all that's left is 2t equaling $14.40. And how do you get rid of the multiplying 2, right? So this was the subtraction property, real quick. All right, subtraction property of equality. All right, we had to get rid of that plus 550. And then how do you get rid of a multiplying 2, right, for that coefficient in front of your t variable? Division property. So that's the division property of equality. All right, so what's $14.40 divided by 2? $7.20, yeah? So a ticket costs you $7.20. So that's one of the reasons we write things as equations. Also, sometimes it's nicer than a big, huge sentence like this. So you guys choose. I mean, do you really want to write things in your entire life in a big, huge sentence form? Or are you going to write it in a nice, cute little equation? I mean, it's kind of like, especially when you get older, you're going to get more tired and straight to the point. Believe me, equations are way nicer to work with than a big, huge sentence. All right. So knowing how to write things out in equation form could spare you a lot of time. All right. So again, what do you want to do? Do you really want to do this, or do you really want to write a big, huge sentence type deal? All right. So example two, Bob earns $25 per hour. So I'm thinking rate. That's a rate. Okay. Whenever you see per hour, okay, I'm thinking $25 per hour, which is really time, right? So I'll use hours. I'll use T to represent time. Okay. And already has 200 bucks. Okay. And his goal is he wants to save $1,000. So that's what he's setting his equation to. All right. So he's going to have $25 per hour plus the 200 he already has. And his goal is what he's setting his equation equal to, which is $1,000. Okay. In life, you always have goals, and you always want to set your life equal to whatever your goal is, so you can work on trying to figure out your variables and what you need to do to achieve your goals. All right. So the main question again is how many hours until Bob gets his $1,000 goal? Well, same situation as last. Now we have to solve for the variable t. We have the plus 200 there. So let's go ahead and start working on isolating t, which is our variable. Okay, our goal is to get t all by himself. So we have this plus 200 on the left-hand side, right? So how do you get rid of a plus 200? Minus. But remember what you do to one side. Gotta do the other, all right? So that, again, is a subtraction property of equality. Very nice. So make sure you remember the subtraction property. The 200s cancel out, and that's good. That means all we have left on the left-hand side is the 25 per hour. Okay, that's my t, sorry. And then 1,000 minus 200 is 800. All right, so how do we get rid of the multiplying $25 or 25, right? What's the opposite of multiply? And hopefully you think division. And just remember though, what you do to one side, do to the other. So again, that's the division property uh, of equality. I know you're like, Mr. Webb, why do you write out all that? Geometry, when we do proofs, that's next year. It's very important you understand the reasoning on why we go from one line of logic to the next. So 800, in your calculator, divided by 25, because again, what you do to one side, do the other, and you should get 32. What does that mean? That means that Bob has to work 32 hours to get to his $1,000 goal. So now Bob knows exactly how much he needs to put in to get to his goal. All right, so your turn number one. Same situation as Bob, just different uh, different coefficients, right? She's not making the same as Bob, and she already has a certain amount saved up. That's not exactly like Bob's situation, right? And her goal is $1,200. So again, not Bob, Karen. Okay. So how many hours until Karen gets to her goal? All right, her $1,200 goal. So same as Bob's situation. All right, so next concept is creating and solving equations with variables on both sides. So if we were to compare Bob and Karen, we would set their two equations equal to one another. Now, in this situation, we have a couple people let's see, Janine has a job offers at two companies. Okay, so Janine, she's got some options. She's comparing two companies. All right, so one company, we'll call this company A, offers a starting salary of 28,000 bucks and will raise $3,000 each year. So 3,000 bucks every year, okay? And I'll use T to represent the years. So 300 or 3,000 bucks per year plus the starting $28,000. Very nice. Very nice. All right, but now she's trying to figure out, and again, this is for company A. Company B, on the other hand, all right, the other company, company B, offers a starting salary of $36,000. Ooh, very nice. That's way more. With only a raise of 2,000 bucks. Wonk wonk. So that's not as great as company A. But now Janine is trying to figure out, well, how many years will the salaries be the same for both companies? All right. And again, the other part of the question is, well, what will that salary be? Well, first things first, if you're trying to compare two different companies or if you're trying to compare two different people and their earnings, you definitely want to set them equal to one another. Okay. So when you do this, now you're starting to solve for the t, the variable. Okay. So what's the difference between the raises per year? So let's try to get and isolate the variable to where the variable's on the left-hand side because you always used to having t equals your answer, right? Your numerical answer, right? If I could spell answer, right? Obviously, I need to work on that. But you always have, x equals some number, right? You guys are so used to that. So let's try to keep that in mind. So let's try to get rid of the 2000t on the right-hand side for company B. How to get rid of a positive 2000t. And hopefully you realized, oh, subtraction. But remember, what you do to one side, got to do the other. Okay, so those will cancel out, which is good, all right, because now there's no more variable on the right-hand side. But remember, this is the subtraction property of equality. All right, and things change now. All right, so 3,000 minus 2,000, that's 1,000. So the difference is 1,000 per year for each company. And then again, we're just moving down our other terms, which we haven't talked about yet. Okay, but now we will. Let's get rid of the plus 28,000 because we're going to try to find the difference for the starting salary now. So in order to find the difference, we're going to subtract company A's starting amount. But remember what you do to one side, do the other. Again, subtraction property of equality strikes again. So I'm putting quotes there because it's really the same thing happening. All right, so we have 1,000t still there, just moves down. These cancel out, which is a good sign. 36,000 minus 28,000. You should get what, 8,000? Very nice. And then how do you get rid of the multiplying 1,000? Because we want t all by itself. So what's the opposite of multiply? And hopefully you already realized it's divide. Just remember though what you do to one side, do the other. And if you want to do this real quick and not need a calculator, again, remember the zeros cancel out, and all you really have is 8 divided by 1, which is 8. And again, that was the division property of equality when we divided by 1,000 to both sides. All right, and t equals 8. That means in 8 years. All right. Now, what will that salary be was the second part. So what we're really going to do is we're just going to plug back in 8 years for our t value. It doesn't matter which company you plug it back in for. I'll plug it in for company A. All right, so if I substitute it back in, substitute, okay, t equaling 8. Remember, company A was $3,000 per year of an increase on top of the 28,000, right? If we plug in or substitute 8 for t, it's really going to be 3,000 times 8 plus the 28k. All right, so your calculator can do a lot of this for you. 3,000 times 8, you should get 24,000 from that. And then you're going to add the 28,000 that she starts with to the 24,000. All right, so you should get $52,000. So in 8 years, all right, comma, Janine's salary will be $52,000. Now, why do you guys need to know this kind of math? If you had this option of two different companies, obviously the one, company B, starting off with 36K sounds really, really good. But if you're going to be there, if you're going to be living there past 8 years, company A is going to be the nicer option because, I mean, yes, 28K is not a lot of money compared to 36,000, but look at the rate in which you get the pay increase, right? So after 8 years is over, company A will be a smarter choice. All right, but if you're only going to be there for a couple of years and then you're going to move, My opinion is definitely company B. You'll make more money. All right. So company B is really about the short term, so less than 8 years. Company A, on the other hand, is long term, so more than 8 years. So if you're working for company A past 8 years, you're in the money. But if you're only going to be there than less than 8 years, then company B is probably going to be more economically awesome for you. So that's one of the reasons we do this. All right, so company four or example four, one moving company. Oh man, I'm hiring one right now. Charges $800. All right, plus $16 per hour. And again, I really do enjoy using T for time. Okay, so that's what I'm using T for. Another moving company charges $720. Okay, plus $21 per hour. All right. So at what number of hours will the charge by both companies be the same? Second part of that question is what is it that they're going to charge? How much, right? So time and money. So let's figure it out. We got let's see. First things first, let's look at our companies. Which one has a greater, so let's say the first company, we'll call it A. Okay. Company A costs $16 per hour and charges 800 bucks just for, I guess, driving out there. Company B, on the other hand, charges $21 per hour plus a measly 720 bucks. Okay, which one has a greater coefficient or hourly rate? Hopefully, you said company B, right? So I want to have company B be on my left-hand side of my equation. All right, and then I'm going to set it equal to company A, which was 16 per hour plus the $800 fee. All right, the reason I did that is because, again, like the other examples, when you find the difference for their hourly rates and you use subtraction property, because I have the 21, which is greater than the 16 on the left-hand side, because I did that, when we use a subtraction property and cancel out the 16t on the right-hand side, when you subtract the 21 with the 16, you actually get a positive 5t. If you did it the other way, if you did 16t plus the 800 equaling the 21t plus the 720, and you subtracted the 21t over here, same process, but you would actually get a negative coefficient, and that could be annoying for several of you. So if you want to stay on the positive side, always have the larger coefficient on the left and the smaller coefficient on the right. Okay. So, okay, so we got 5t, all right, plus the 720. We're going to just move that down, equaling the 800 because the 16s, we got rid of them. And again, that was a subtraction property of equality. Just give you that heads up. And again, how do you get rid of the 720? Because again, we want t equaling our answer, right, which we know is going to be a numerical one. So how do you get rid of the plus 720? Subtract it, right? Subtraction property once again. Okay, very helpful. These cancel out like we want. All that's left on the left-hand side is 5t. And then 800 minus 720, you should get 80, right? And then how to get rid of a multiplying 5? Hopefully you said divide. All right. So what's 8 divided by 5? That's 1 with a remainder of 3. So you have 30. What's 30 divided by 5? 6. So 16. 16 what? 16 hours. So 16 hours. But remember, that's our first part of our answer. We still have to substitute it in to either company A's equation or company B's, all right? So company A had a smaller coefficient, so I'll just use company A, okay? But if I did use either one, would it matter? All right, let's find out. Company A, 16 per hour. So 16 times 16 plus 800. And then company B was what? 21 per hour times the 16. Okay, 16 hours. So we're plugging it back in for both, plus the 720. All right, so real quick in your calculator, all right, make sure you're doing this with me. 16 times 16 equals 256 plus the 800, and you get what, $1,056. Now do the same thing for company B real quick. All right, 21 times 16 equals 336 plus the 720, and how about that? We get the same thing. So does it really matter which one you plug it back into? No, because you set them equal to each other, and that means at that particular hour, on the 16th hour, both companies are going to cost the same amount. All right, so this is part one of the question, and then this is part two of the question. All right, so your turn number four. We got a veterinarian changing the diets of two animals, Simba and Cuddles. Simba currently consumes 1,200 calories per day, so I'm thinking a rate of change there. Day, you could use T for time. That number will increase by 1,000 calories each day. Oh, okay. So this is what he starts off with. All right. So I'll give you a hint: 100 calories per day plus the 1,200 calories that he starts off with. And so that was what? That was Simba. That was his equation. You guys, on the other hand, have to figure out. Let's see. That number will decrease by 1,900 calories. Oh, Cuddles. Cuddles currently consumes 30 calories a day. Okay, so Cuddles, he currently consumes, that's a 3, a very terrible, sloppy 3, 30 calories. But he decreases. Decreases is not growth. That is decay, my friends. So minus 1,900 or 100, 1,900 calories. That would be, oh, he would be gone in like a day. 190 calories per day. Now, how do you guys solve for this? Again, set them equal to each other. Solve for t. Now, again, what's the opposite of minus, right? Minus 190t. What's the opposite of minus? And that should get you started on trying to solve for them. So try to figure it out. You can work in groups on this one. All right, so just remember, how many days will that be when they are the same number of calories? That's part one of the question. Part two is, well, on those many of days, right? How many calories will the animals be consuming that day? So whatever you get for part one, plug it back into your equations, either one for Simba or Cuddles, and that way you can find your answer for part two. All right, so there's your homework, page 62 through 64, numbers 1 through 7, and 13 through 14, which is a lot like the Cuddles problems, setting things equal to each other and solving. All right, guys, check this kid out. He's like, blah, da, 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 and this girl's just like, Sharukin. Look at that. I didn't even know you can go backwards like that. She just, dang. Good morning. That guy's just like, dang. All right, have a good day, guys.